Okay, so I've gone into Desmos and I've got my final project put together. That is, I've got the picture of the horse with the sway back imported into Desmos. I've typed in that equation, which we can see down here as the blue line. I've typed that in for my calculator, and I'm going to talk about how good it is a little bit afterwards. I'm just going to show you how I did these things. So I'm going to turn the picture of the horse off, and I'm actually going to add it from scratch. So I'll go to Add Item, Image. Now I had the picture saved in my downloads, and you'll see when it shows up, it's really, really small. So it's all the way down at the origin. So I'm going to make it a little bit bigger. Now I changed the size, the width and the height to match the width and the height of the actual picture that I had taken this from. So it was 693 pixels by 629 pixels. And that makes sense because I want my scale of my diagram to match up with my scale of my points that I had sampled. So 693 and 629. But the problem is now it's got the horse dead center and my equation is modeled somewhere over here. So what I did was I said, okay, I don't want the center to be on the center of the image at 0, 0. I want the center of the image to be at halfway down the width, so 693 divided by 2, and halfway down the height, so 629 divided by 2. I thought that's pretty good, but you can see my curve kind of is a little bit back and to the left. It's a good reference to an old movie there for you. Now remember I had this star down here, and that star was actually my reference point, and I had that set at 0, 0. I can translate each of these points. So I'm going to go, okay, I don't want the center to be at this value. I want it to be a little bit further to the left. So I'm going to take it and move it 10 over, and you'll see the star moved. And I had found that the best movement was 23 units. And I just played around with it. So I maybe went a little bit over the first time and then said, no, that didn't work. Go a little bit under the second time. I need a little bit more. So then I just kind of counted up until I got to 23, although 24 looks pretty good too. I can't tell the difference. I think 23 is on the left and 24 is on the right. So that process for the vertical then, I know it needs to come down, so I'm going to subtract. Maybe I'll subtract 50. Well, that went down pretty good. Let's try 40. It's somewhere in between, so 45. And I think that that looks pretty good for center. So that reference point that I had of the star is now at the dead center. Now, unfortunately, my model for my horse curve kind of stops right there. Like that's the last point that that curve really makes sense. And it also kind of stops right there. And you can see that I miss a little portion here, and I miss a little portion there, and I miss a little portion here, and I kind of cut across the back of the horse in these two sections as well too. So it's not a perfect graph, but had I sampled more points, I would have been a lot closer to actually matching the curve of this horse. These extrema, so these points at the maximums and the points at the minimums, the more points you sample, the tougher it is to get those extrema to necessarily lie perfectly flat. But this is a fairly good approximation. Like if I had to say I've modeled the horse's back, I mean, at least I've got around the height from the top of the withers down to the bottom of the sway. I've got a fairly good measurement of that. And if I were trying to calculate, I don't know, the slope of the horse's back at any one point, I think that I've got a pretty good approximation of that here. And so this is how you can use sampling and your TI-84 and quadratic regression to put together a function that defines the outside edge of something.